Okay, more about the normal distribution. This is titled the standard deviation, standard normal distribution. I'm going to change the title to more normal distributions. Okay, it's just we're going to be using our calculator to be calculating areas now. We're not going to use our brains and the empirical rule. We're going to be able to use our calculator to find these percentages. And we're going to be able to answer questions by turning things into standard deviation distances and then finding like the percentages either below or above or between certain values. Okay? First, you need to be introduced to z-score notation. Okay? Now, what is a z-score? A z-score is how many standard deviations away from the mean you are or your data is. Okay? So if I say z equals 1.2, this means whatever the data you're talking about, your data is 1.2 standard deviations greater than the mean. This is a point. Okay? And if I said the z is equal to negative 2.56, that would be saying your data point that you're talking about is 2.56 standard deviations less than the mean. And you could kind of plot those values on your normal curve. So if I had 1.2, 1.2 would be like here, this far away from the mean. And we could find the, not knowing, right, not now, we will not be able to find the percent greater than or the percent less than, because we don't know about like any empirical rule at 1.2, but we will be able to find the percentage greater than the percentage less than using our calculator. Okay, negative 2.56 would be right here. And we might be able to find the percentages less than that value and percentages greater than value. We're going to use our calculator. Okay. Now, instead of saying what is the percentage of your data points that is greater than 1.2, there is a shortcut notation. Okay. This P with parentheses Z notation is a shortcut notation to ask questions. For quick questions. For example, let's just forget about that one. P parentheses negative 2 less than Z less than 2. This is a shortcut way of saying what is the percentage of your data that is between negative 2 standard deviations away from the mean, or 2 standard deviations less than the mean, and 2 standard deviations greater than the mean. Okay? So this question corresponds to, this area. What is the percentage between negative 2 and 2? That makes sense? That's what this question is asking. And you already know the answer to this question. Just using the empirical rule in your brain, what is it? 95. Yeah, 95%. Okay. This question is, what is the percentage of your observations that are greater than 0 standard deviations away from the mean? Or, what is your percentage of your data that is greater than the mean? You should know this answer is what? Yeah, 50%, going to the right. Same question. What is the percentage of your values that are less than 1? Remember, this is 50, and then this is 34. So 50 plus 34, 84. Greater than -2, we had 50, and then we had 95 divided by 2. That's 47.5. So 50 plus 47.5 is 97.5. Okay? These are all kind of questions that are now quickly asked using this notation. What is the percentage of your observations within these amount of standard deviations? Now, you guys figure out what it is for the percentage of your values that are less than -1. So that would be these. What do we get? What do we get? 16%, right? 50% is to the left of 0. 34% is between 0 and -1. This is 16. Okay? Cool. Well, guess what? Get out your calculators. We'll be able to find all of these values without using our brains. Isn't that great? No more brain usage needed. We can just use our calculators. We can find the percentage values of any z-score with a calculator. We can answer all those questions with a calculator. We're going to introduce ourselves with the normal CDF command. Now, to find it, you are going to second DIST or DISTR. It depends on what kind of calculator you have. It is over VARs. Let me get my calculator out and I'll show you where it is. Clear this. So, right here is VARs. Above VARs, DISTR. And I go second DISTR, and then I see number 2 is normal CDF. Okay? Now either it pops up like this, or this shows up on our calculator, right? Okay? Well, what we put here on our calculator is the lower z-score and the upper z-score. Okay? A lower z-score and an upper z-score. So say we want to figure out the percent between the -2 standard deviations away from the mean and 2 standard deviations in the mean, which we know the answer is 95%. Our calculator can show us that that's correct. I can type in here between -2 and 2, skip this and just press paste and press enter, and you're going to see a value really close to 95%. Or if this shows up in my calculator, where it's just normal CDF, you will type in -2 as your low end, comma, 2 as your high end, and you will press enter, and I get 95.44%. So it turns out the empirical rule that we learned, the whole 68, 95, 99.7%, that was more of an approximation. This is an actual exact value. Okay? Approximately 95% of our observations are between -2 and 2 standard deviations from the mean. Our calculator just shows that. Okay? Confirm between -1 and 1, you get 68%.
Normal
CDF, yep.
Okay. And
then from -2 is the lower, that's the bottom. The top is upper. Okay? 2. And then paste. Enter. There you go. Okay. That's okay. We should see 68%. I want to see everybody's calculator 68% between -1 and 1. Anybody having troubles? Need help? Dister, above bars. Second dister. Normal CDF. Nope, that was normal PDF. Yes, it's 68.3. So it's approximately, our empirical rule turns out was not exact. It's an approximation. Now the lower is your low value that you're going to place, which is -1. And the upper is 1. What lower and upper are z values. These are z values. These are standard deviation values. Okay? Z values go here, standard deviation. And in the other one, if you don't have this lower and upper and just normal CDF shows up like in my calculator, you're also just plugging in standard deviation values, okay? Now, here's where it gets a little tricky. What if we wanted to find the percent lower than -1.2? Okay, so this is something that I don't know. I know between 1 and -1. I know between 2 and -2. I knew between 3 and -3. But once I change up my values, I'm going to have to use my calculator. Okay. Well, here's the trick. I'm not going to go. I don't really have a specific value I can plug in over here on the left. Okay. Because if you think about it, this kind of goes all the way out. And it will approach 0. It'll never touch 0, but it'll get really, really close to 0. Okay, so I can't really plug in negative infinity really in my calculator. My calculator doesn't deal well with infinity. And the same thing if I went to the right, I can't plug in positive infinity. Instead, what you will use for a minimum and a maximum as a lower or possible upper bound will be just -10 and 10. Okay. -10 will be your lowest z value you'll use, and 10 will be the highest. That's because 10 standard deviations less than the mean will pretty much cover practically all of the area underneath it, and if you go beyond it, it'll be so insignificant that it won't even show up on your calculator. Same thing if I went higher than 10 standard deviations above my mean, it'd be so far away that anything higher than that wouldn't even show up on my calculator, okay? So here is where things get a little bit more difficult. If I wanted to find the probability of z values less than -1.2, I'm going to use my normal CDF, but this area here, which is less than -1.2, I will say is between -10 and -1.2. And that will give me all of my area below this. Okay? Figure out what that is. We will say that less than 1.2 is the same as between -10 and 1.2. And we should get 0.115. 11.5% of my values would be less than 1.2 standard deviations below the mean. Did we all get that 11.5? Good. Well, guess what I would do if I said, what is the probability? Take that out of your ear. It's super disrespectful. Thank you. I don't want to see that again. I'm going to take your phone, okay? What is the probability of my z-scores greater than -1.2? Well, all of a sudden things shift, and we're not talking about this area below. We're talking about the area above. That's this area up here. This is going to be the same as between -1.2 and +10. That will be my upper bound, okay? So you guys figure out what that percentage is. I know it's going to be easy to find because it'll just be the remainder of the area, 100 minus this area, 11.5. But you guys can figure it out. What is the probability of your data being greater than negative 1.2? There you go, 88.5%, 88.49%. Okay, do we all get 88.5 in our calculators? Lower. That's our bottom. Upper is our top. Small value, large value. If I wanted values lower than negative 1.2, I say it's the same as between negative 10 and negative 1.2. If I'm talking about greater than negative 1.2, I say that's the same as between negative 1.2 and 10. So negative 1.2 is your lower, 10 is your upper. Switch it up and do it greater than. We should get 88.5. Now you got negative 88.5 because you went from 10 to negative 1. We want to make sure the low value is first and the high value is second. Okay? If you ever get a negative value, it's because you did them in the opposite order. Make sure your small value, which is negative 1.2, comes before your large value, which is 10. So it should be from negative 1.2 to 10. So this should be negative 1.2, and then this should be 10 in this situation.
So the lower you say.
The small value, negative 1.2, and the upper value is always going to, so you're always going to put the lower is always your smaller value, and the upper is going to be the larger. So in the first case, it was negative 10 to negative 1.2. Second case will be negative 1.2 to 10. Okay? It will just always be, if you look at your two numbers, whichever one is the larger, more positive, will be upper. Whichever one is more negative is be the lower. Okay, so let me give you a couple more. Practice. Give me the following. P that is between negative 2 and 1.5. Give me P that is less than 2.3. And give me a P that is greater than negative 0.5. What's that? Yeah, we're only talking about if our mean is 0 and our standard deviation is 1. This is the standard deviations away from the mean, right? So all the same. This is all Z scores. This is 2 standard deviations less than the mean, 1.5 standard deviations greater than the mean. What's going to help me is to sketch normal curves and your areas. So I'm going to kind of sketch a normal curve, and I'm going to say, okay, negative 2 is around here, 1.5 is around here. This is the area that I need to have. So I'm going to be thinking of a value that's like fairly substantial, probably bigger than 50%. So then I'm going to look at my answer, and I see, and I can check, does that answer make sense? Now the next one, less than 2.3. Well, 2.3 is over here. I'm going to talk about another pretty substantial value. Greater than negative 0.5. Negative 0.5 is pretty close to the mean. Greater than is going to be a little bit bigger than 50%. And let's do another one. Why don't we do z greater than 1.56. Yes. 2.3, yes. Less than 2.3. Why don't we compare our answers with the neighbors, and let's see how we're doing on these. Yep.
Okay, so which one?
Which one are you doing?
Well, I'm not talking about that.
Okay.
So if I go to this, then I go to 2, it goes to that. How do you, because you were just kind of typing them in, weren't you?
Right, you're just typing them in.
Is that okay if I do it this way? Like it goes to this? Because I know you had like, if you like click enter.
Right, I'll go to it. No, yeah. I'm saying that some calculators go straight to that, and you could just type it into that.
Oh, okay.
So you just type in your low, then your up. Your lower value, then your upper value. Just whatever you want.
Okay.
Yep. Nope. What would you put in? I want to go all the way to the left. What is the lowest value that we'll type in? Negative 10. Exactly. Exactly. Okay. Greater than a certain thing, we'll say is between our value and 10. Less than a certain number, we'll say is between our value and negative 10. Of course, negative 10 is going to be the first one, and your other value would be the second. Okay? Check your answers. Let's make sure we are all on the same page. For the first one, yeah, sure. That's the easiest one, right? Right. Yes. So second DISTR and then normal CDF. Okay, so yours, it just will pop up like this. You will have to type in yourself the lower, comma, your upper.
All right.
Just the lower comes first, the upper comes second. Okay? That makes sense. It's a little bit bigger than 50. All right. Miss Rios, what did you get for number 2? 98%. Miss May, can you concur? Did you get 98%? All right. We should have gone from negative 10 to 2.3. Notice how sketching this helps me figure out the values that I need to plug in. Mr. Ingleton, what'd you get for the third one? 30.85 does not sound or look correct, right? Why not? Because if we're greater than negative 0.5 standard deviations from the mean, I know that's going to be at least 50%, because the mean's right here, negative 0.5, and if I'm talking about greater than, it needs to be bigger than 50%. Fix your answer. What's up? Negative 0.5 is the low end. The upper end, which is all the way to the right, we'll say is 10. There you go, negative 0.5. What do we get, Mr. Englander?
69.15.
Good. We'll just round to 69 and just call it, okay? What about the last one, Miss Weldon? All right, do it right now. What's up? Oh, why not? Because it's on the bottom. Okay, it is z greater than 1.56. Okay, Miss White, make sure you do it as well. You guys can confer with each other, and we'll make sure that we get the right answers. Notice my graph is going to help me determine the values that I'm going between. What are you plugging in, Miss White, for your values?
1.56, and for the lower and 10 to the upper.
Perfect.
I got 5.9%.
Which makes a lot of sense because we're talking about just a little skinny area. Ms. Weldon, did we get the same thing? Yep, 5.9%. Perfect. Okay, any questions about this? Good. Let's go back. Go away. Nope. Arrow. Go away. All right, good. You already did this. Let's talk about finding a z-score. So now we know how to find these percentages as long as we have z's. Well, we're going to have to turn values into these z-scores. Okay, and this is a very important formula that you need to write down. What this formula does is it standardizes things. It turns data values into standard deviation distances. Okay, this is how we calculate how many standard deviations a data point is away from the mean. Not the man, from the mean. Okay, if we get a positive value, that means we're greater than the mean. If we get a negative value, that means we're less than the mean. We're above or we're below. Positive is above or greater than, below is less than the mean. Okay? And really, this observation is just like your data that you're given, your certain points. The mean is your mu that you will be told, and your standard deviation you will be told. Okay, all three of these you will be told. Okay, and all this does is it turns it into a z-score. It turns it into a standard deviation distance. Okay, let's do a couple calculations to find some standard deviation distances. Don't want that. Here we go. Caterpillars' heights are normally distributed with a mean of 2 inches and a standard deviation of 0.5 inches. What is the z-score of a caterpillar with a height of 2.68 inches? What that question is asking is how far away is that caterpillar's height compared to the mean in terms of standard deviations? Okay, you will just use your formula. This right there, the 2.68, this is what we would consider our observation. We know that this is our mean and this is our standard deviation. So our z-score is going to be our observation minus our mean over our standard deviation. Okay, you guys use your calculator to find this? Point five. Now, really quick, let's just make sure we are using good calculator etiquette. If I'm trying to divide things and subtract things, I cannot do it in a row like this because my calculator is going to divide 2 by 0.5 first and then subtract it from 2.68. This is incorrect. This is incorrect. Instead, you must tell your calculator to obey the order of operations by either using parentheses around that numerator or just going one step at a time. I would probably just recommend you do 2.68 minus 2 first. Press enter. That gives you your number. And then you divide that by 0.5 to get you your z-score, 1.36. Or you could have done it all in one row if you use parentheses, making sure you are telling your calculator to subtract these two numbers first before we divide by 0.5. Okay? We get 1.36. That means this caterpillar dude is 1.36 standard deviations greater than the mean. That's what it means. That's how far away he is from the mean. Okay? Okay. NBA players' heights are normally distributed with a mean of 77 inches and a standard deviation of 4 inches. How far away from the mean is Nate Robinson, who is 66 inches tall? I can ask you the question, which is the same as the first question. It's just asked a little bit differently because I asked, how far away is Nate Robinson on a standard deviation basis? And what do we get? Negative 2.75. Now notice, it's okay to have a negative value. You're not going to put your bigger value first and your smaller value second. You're always going to put your mean second. So, yes, 66 will come first because that's our observation. That's how tall Nate Robinson is. I just guessed on that. I'm not sure exactly. And then I will subtract the mean, divide by 4. This should make sense. Nate Robinson is smaller than the average NBA player. In terms of standard deviations, he's 2.75 standard deviations less than the mean. Okay? So he's on the low end of our normal curve. There will be not that many people smaller than him in the NBA, but a whole lot of percentage of the players will be taller than him, if you think about the normal curve. He's like right here. Huge percentage would be taller than him. Okay? Finally, SAT math scores, I just looked this up. This is for last year, are normally distributed with a mean of 511 and a standard deviation of 120. Calculate how far away your score was from the mean on a standard deviation basis. Did everybody take the SAT? No? If you didn't take the SAT, pretend your score was a 600. I got 0.74. This is not a percentage. This is the standard deviations away from the mean. So I'm 0.74 standard deviations greater than the mean if I got a 600. Well, guess what we can do with this information? We can use the normal CDF to figure out the percentile that I was in, to figure out how much better I did than what percentage of all the students. All of a sudden, I can go normal CDF. Oh, I'll go back. I can go normal CDF and go from -10 to 0.74, and I could figure out that, hey, I did better than Dister, normal CDF, -10 to 0.74. I did better than 77% of all students. You guys figure out what percentage of students you did better than on the SAT math if you had a different score than a 600. Right? Because what I'm doing is I'm taking the percentage underneath 0.74 on my normal curve. Here's 0.74. There's the percentage. I did better than 77% of all students who took the SAT math test. Go from -10 to 0.74. Okay? And this is the basis of what we're doing, and this is giving us to our last thing, which is combining finding z-scores and finding percentages using our calculator to answer questions. Okay? Answer questions involving normally distributed data. And here's how you're going to answer questions when your value is not going to be a whole standard deviation from the mean. Write down these steps. Step 1, you're going to find your distance in terms of standard deviation, your data point is from the mean, or you're going to find the z-score. Step 1, find your z-score. We will turn data, which is in inches or in, a number, in, I don't know, in terms of money, who knows. We'll turn that data into standard deviations. Now, step 2, and this is what I always recommend to my students, we're going to sketch on the normal curve the area that we're going to try to calculate. Okay? And then the last step is we're going to use the normal CDF to calculate that area. Let's take the last example that we did on the z-score. I could ask you, what percentile is a 600 math score if the SAT math has a mean of, 512? 511, and the standard deviation of what? 112, 120, 120. Okay, so what percentile are you going to be in? Well, step 1, you would find the z-score. It's okay, well, my observation is 600. I subtract 511, divide by 120, and what did I get? 0.71, 0.74. Okay, that is my z-score. Second, I'm going to sketch on the normal curve the area I want to calculate. So I'm going to sketch a normal curve. I'm going to say, okay, this is 0 right here. 0.74 is going to be like right around here. I'm just going to approximate it. And I want the percent that is below this. So then I'm going to say, oh, that's going to be between -10 and 0.74. So my last step that I'm going to do is I'm going to type in normal CDF. And then my lower will be -10. My upper will be 0.74. And what did I find was the percentage? 77%. I did better than 77% of students. These are the types of problems we're going to do. Okay? Okay, here we go. First problem, another SAT problem, I believe. Overall SAT scores for the 2009 incoming class of the University of Texas had a mean of 1815 and a standard deviation of 252. Okay? A University of Texas student got a 1901. What percentage of all UT students did better than this student? So, Let's walk through it. Step 1, find your z-score. Go. Once you get your z-score, compare it with a neighbor. Remember, z-scores are not percentages. They are distances. So even if you get a decimal, don't think that's a percentage. That's a distance. In terms of standard deviations, that person's score is away from the mean. Ms. Funko, what did you get for the z-score? 0.34. Good. We took our observation, 1901, we subtract our mean, 1815, and then we divided by 252, and we got 0.34. Good. Step 2, sketch the curve. Okay? 0.34 is going to be a little bit to the right of 0, right? Now, what area am I looking for? If 0.34 is right here. The area to the left of 0.34 or to the right? Let's read the question again. What percentage of all students did better than this student? The right. Okay. So we're going to go over here. We're going to sketch to the right. Now, here's a really quick way for you to make sure your answer is correct. Is this greater than or less than 50%? Less than, right? Because from 0 to the right is 50%. So I'm going to get an answer that's going to be a little bit less than 50%. Okay? Step 3 is to use normal CDF to calculate your percentage. The upper would be just all the way up here as far as you can up, which we always say is going to be 10 standard deviations away from the mean. It's so far up here, this would be the maximum standard deviation you can be away from the mean. Remember, the maximum value we will always use is 10. The minimum value we will always use is negative 10. We can use different values, actually. We could use 1,000 and negative 1,000. We could use 100 and negative 100. But the answer will not change at all because the area underneath the curve will be minimal. Okay? So I do that. I found my value, and I get what, Mr. Johnson?
37.
Good. We have a lower of 0.34 and an upper of 37. Sorry, whoops. Upper of 10. And I find out that, yes, it is lower than 50%, only 36.69, or about 37% of students got a better SAT score than that one student. Okay? Everything makes sense. We just did this problem. Next problem. Gonna erase this. First answer was 37%. Second question, what percentile was a student at if he made a 2200? 2200. Go. Make sure you do step 1. Find your z-score. Step 2, sketch the area you're going to find. That way your answer will make sense to you. Step 3, use normal CDF, making sure you have your low value and your up value to find this percentage. Simpson, what do we get for our z-score?
1.5.
1.52, good. 1.52 up here. This is my sketch. I'm going to find this area down here. Area is definitely bigger than 50%, right? Okay, good. So that will help me make sure my answer is correct. Mr. Soanes, what are the values you used in your normal CDF?
-10 to lower point 1.52.
Perfect. The lower is all the way down here at -10. We'll say that lower than 1.52 is the same as between -10 and 1.52. And what's the percentage that we got, Ms. Nebergich? 94% looks good to me. Okay, next question. Sure. 94% is what we got, Mr. Rios. Let's do this first question. Born to Run, a study of elite distance runners found a mean body weight of 139.1 pounds and a standard deviation of 10.6 pounds. These are for all you distance runners out there. Assuming the distribution of weights is approximately normal, don't worry about making a sketch. Let's just answer question number 1. What percent of runners would have a body weight between 107 and 149.7 pounds? Go. This is different. This is having to calculate 2 z-scores. I know. One 139.1, 10.6, 107.3, 149.7. I don't remember those. What was the standard deviation? 10.7? 10.6. We wanted between what 2 values? And 139.1? 149.7. Good. Okay, go. Step 1, z-scores. Find your distance. Those observations are away from your mean. Ms. Devries, what do we get for our first z-score? -3 on the dot. Ms. Bushman, what'd you get for the second one? 0.1. Did we get 0.1 or did we get 1? 1. Ended up getting 1. Okay? So we want to figure out what percentage is between -3 and 1. Well, we could actually have done this without our knowledge, just with our knowledge of the empirical rule. But let's see what it'll look like between -3 and 1 will be this area here. Fairly substantial. We shouldn't be talking about a small percentage. I'm thinking 80s, maybe 90s, probably 80s. Step 3, I'm going to find my z between -3 and 1, my percentage. So I go normal CDF, -3, 1, and what do I get? Look at that, 80s. Perfect. 84%. Great guess, Mr. Messner. Okay, now here's the deal. Listen. You need a calculator to do this homework, right? Your homework's out of the book. What's a good time to do your homework? Right now. Because you have calculators, you have me, and you have books. Hopefully, if not, there's 2 books that we can share. So please utilize this time. I hate calf time. So make me hate calf time less by doing your homework. And if you are portaled, go portal yourselves. Yes.